Hi, my name is Dalton and I work at ANA, the Brazilian National Water and Sanitation Agency. I will talk about our effort to implement a satellite-based monitor of chlorophyll-a concentration in reservoirs of northeastern Brazil. ANA is responsible for managing the National Hydrometeorological Network, which is a set of stations mainly focused on the monitoring of water level, discharge, rainfall, and suspended sediments. As for water quality, on the other hand, ANA depends on the monitoring programs of the state agencies. And often the sampling frequency of such monitoring programs are not high enough to capture the temporal dynamics of water quality. The phytoplankton biomass, for example, may vary substantially in a matter of days. That's why ANA has an international cooperation with the IRD from France, aiming at the implementation of satellite-based monitoring of both water quality and water quantity. Our main goal is to establish a network of virtual stations and use archived satellite data to generate time series of several water quality and hydrological variables for monitoring points, monitoring sites throughout the country. One of the regions we are especially interested in is the Brazilian semi-arid region. It's a huge region encompassing more than 1,000 towns and almost 30 million people. Because of the dry climate and frequent droughts, water uses are majorly dependent on the water stored in public reservoirs. Nevertheless, many of those reservoirs undergo eutrophication, which is facilitated by a combination of factors such as high temperature and insolation throughout the year, long water residence times, and nutrient input from urban sewage and agricultural activities. Even so, many of those reservoirs are poorly monitored for the chlorophyll-a concentration and for water quality in general. The remote estimation of water quality parameters from satellite data is therefore a desirable complementary effort in the region. We gathered field data from 13 reservoirs of different size and eutrophication levels, and combined those data to satellite images in order to develop a model for remote chlorophyll-a estimation. We then applied the model to archived imagery to generate synthetic time series. Here we have three examples. The red line is the reservoir water level, and the black one is the chlorophyll concentration. It's possible to observe that during periods of steep increase in water level, the concentration falls to the lowest levels, presumably due to dilution and to the loss of biomass. In turn, during droughts, as the one began in 2011, the chlorophyll-a concentration tends to remain high, impairing water quality exactly when water availability is low. So these are examples of the results we have so far. We still need a lot of improvements. For example, our model does not deal well with transitory conditions, where both phytoplankton and inorganic particles are present in high concentrations. We also need to estimate other water quality parameters and to spatialize the results on water quality maps. That was all I was going to explain today. Thank you very much for watching.